Hey guys, in this video we're going to be talking about how to find parametric equations for the line of intersection of two planes. The first plane is x plus 2y plus 3z equals 1. So let me label that plane 1 just to keep our work organized. And our second plane is x minus y plus z, which equals 1. And this is plane 2. Perfect. So let's get started. The first thing we need to do when finding parametric equations for the line of intersection of two planes is finding the normal vectors. So step one, normal vectors. And to find the normal vector, we're going to be taking the coefficients in front of each variable for each plane. So for plane 1, our normal vector is going to be labeled as n1, and that's going to equal our coefficient. So the coefficient in front of x is 1, so I'm going to write a 1 over there, comma, the coefficient in front of y, which is 2, and the coefficient in front of z, which is 3, so comma, 3, and then close your parentheses. And that's your normal vector for plane 1. Now for plane 2, so plane 2, your normal vector is going to be your coefficients in front of each variable as well. So for normal plane 2, which is n2, that's going to equal 1 for x, negative 1 for y, and positive 1 for z. So those are your normal vectors. Now that you have your normal vectors, it is time for us to move on to step 2, which is finding the cross product of our two normal vectors. So I'm going to label our result for the cross product with the letter V, and that's going to equal our matrix IJK, and then on the second row, I'm going to have plane 1, so the normal vector from plane 1. And in the third row, I'm going to have the normal vector from plane 2. So that's 1, negative 1, and 1. And then I'm going to find the determinant. So this would be I times 2 times 1 minus 3 times negative 1, that is 5. So I'm going to write a 5 over here, minus j times, so for j would be 1 times 1 minus 2 times 1, that is negative 2, plus k times 1 times negative 1 minus 2 times 1, that is negative 3. I can simplify this or write this better to equal 5i plus 2j, because we have a negative and a negative, minus 3k. I could also write this as 5, 2, negative 3. And this is what v equals. Okay. Now that we have our cross product, it is time for us to move on to step number 3. And in this step, it is finding a point on the plane. Point on plane. Okay, so for this one, I'm going to write our two equations over here. So x plus 2y plus 3z equals 1. And then for the next one, we have x minus y. So x minus y plus z equals 1. Okay. The best way to solve for one of our variables is by setting another variable, or one of them, to 0. So in this case, I'm going to set z to 0. You can set any variable to 0, but I'm just going to choose z. So set z equals 0. So now we're going to have our two equations. So x plus 2y equals 1, and then x minus y equals 1. Now I'm going to use substitution to solve. So looking at this equation right here on our right, I can say that x equals 1 plus y. And I can take this value and substitute it over here for x. So we're going to have 1 plus y plus 2y equals 1. So then I'm going to have 3y plus 1 equals 1. So then we get y equals 0. Now that we know that z is 0, we know that, let me use a different color real quick, z equals 0, y equals 0. To solve for x now, we need to plug this value back into either this equation or this equation. I'm going to choose the right side because it's more simpler. So x minus 0 equals 1. So now therefore x should equal 1. Okay, now that we have our 3 points, I can put it in the format of p equals, or the point is 1, 0, 0. Sorry. There we go. Okay, now this is our last step, number 4, which is use the form. So the form for a parametric function is x, y, z, which equals x naught, y naught, z naught, plus tv. Let's start with x. So we know that x equals, so our point, which we get from over here, so right over here, we know that it is 1. And then we have to include the plus sign, so plus t. And our v's are cross product. So let's go back up here to our cross product, and if I label this x, y, z, our x value is 5, so I'm going to write times 5 over here. And I could write this as x equals 1 plus 5t. Now for our y, so y equals, again, we're going to go back to our point. It's 0, so x, y, z. Our y value is 0, so 0 plus t, so our t. And then we go back up to our cross product and we have 2 for y, so times 2. And we can rewrite this as y equals 2t. And lastly, for our z value, we have our point, which is 0, plus t times our cross product of, which is -3. Okay, and I can rewrite this as z equals -3t. And that's our answer. So the parametric equations for the line of intersection of our two planes are x equals 1 plus 5t, y equals 2t, and finally z equals -3t.